Welcome! This is Raina Fitzgerald, and in this lesson we are going to look at solving rational equations. Here's our first example. We have an equation with rational expressions. The first thing we want to do is make it addition here, so we're going to add the opposite. Now we see that we have a 4 in the denominator of the first term and a 5 in the denominator of the second. 4 is 2 times 2. 5 is simply 5 times 1. So what we want to do is we want to multiply both the left and the right hand side by 4 times 5, which is 20. So let's move this up. And we're going to multiply the left hand side. So let's rewrite the left hand side. We have x over 4 plus a negative x over 5 is equal to 1. And we're going to take the entire left-hand side and multiply it by a 20. And what we do to the left, we must also do to the right to keep our equation balanced. When we do this, the 20 will be distributed to the x over 4, giving us 20x over 4 plus, now we're going to distribute the 20 to the negative x over 5, and that gives us a negative 20x over 5. Then on the right-hand side, 1 times 20 is 20. Now if we look at the first term on the left, 20 divided by 4 is 5. 20 divided by 5 is 4. So what we have on the left-hand side is 5x plus a negative 4x is equal to 20. Now we combine like terms on the left-hand side. 5x plus 4x is 1x, or x, and x is 20. And let's box our answer. X is 20 is the solution to the original equation. Here we have another example of an equation with rational expressions. The first thing we want to do is change the subtraction to add the opposite. Careful here. This is a negative 1, and when we change this to add the opposite, we are actually making this entire binomial negative. Let's move this up and take a look at this. So here I've rewritten the equation, and what I want to do now is distribute this negative sign to both terms in this binomial. If we distribute the negative sign first to the x becomes negative, and then when we distribute the negative sign to the negative 1, the negative 1 becomes positive. So what we end up with is a negative x plus 1. Okay, so I've rewritten this equation again, and this time I want to look at the denominators. The denominators are 30, 5, and 10. What I want to find is the least common multiple of 30, 5, and 10. And I determine it to be 30 because 30 goes into 30 once, 5 goes into 30 6 times, and 10 goes into 30 3 times. So now that I have the least common multiple, I want to multiply both the left and the right hand side by the least common multiple, 30. When I multiply the left-hand side by 30, the 30s cancel out. And I get x plus a negative 5. Now I'm going to distribute the 30 to both terms on the right-hand side. And I get, for the first term, I get 4 times 30 over 5 And for the second term, when I distribute it to the second term, I get 30 times a negative x plus 1 over 10. Now I can see here that 5 goes into 30 6 times. 10 goes into 30 3 times. So now what I have is on the left-hand side I have x plus a negative 5. And on the right-hand side I have 4 times 6, which is 24, plus 3 times a negative 1, negative x, so it's a negative 3x plus, I'm going to distribute the 3 to the 1, so plus 3. Okay, and now what I want to do is combine like terms on the left and right. Well, the left-hand side I have x plus a negative 5. And on the right-hand side I have a negative 3x plus 24 plus 3 is 27. Now what I want to do is remove the negative 3x from the right and get it over to the left. What we do then is to the right-hand side I add the additive inverse of a negative 3x, which is a positive 3x. What I do to the right, I must also do over here to the left. So I must add to the left-hand side a positive 3x. And when I do this, the positive 3x plus the negative 3x cancel out. And then I'm also going to, I want to get the negative 5 out of the left-hand side. The additive inverse of negative 5 is a positive 5. So I'm going to add positive 5 to the left and also to the right. And when I do that, the positive 5 and the negative 5 on the left-hand side add up to 0. So let's combine like terms now. A positive 3x and a positive x gives us a 4x on the left. And on the right, we have a 27 plus 5, and that gives us a 32. And we are almost done. We want to remove the coefficient of 4 from the x because we're solving for x. So I'm going to multiply the left-hand side by the multiplicative reciprocal or inverse of 4, which is 1/4. So if I multiply the left-hand side by 1/4, I must multiply the right-hand side by 1/4. 1/4 times 4 is 1. So 1x, or x, is equal to 32 times 1/4, which is 8. So the solution to this equation is x is equal to 8. Here's another example of an equation with rational expressions. Let's start by changing the subtraction to add the opposite. I'm also going to change the 4 to 4 over 1 so we can see these as 3 fractions. Now let's look at the denominator. The denominators are 1, x, and 2. So we need to find the least common multiple between 1x and 2. Well, the least common multiple is 2x. Because 1 goes into 2x 2x times, x goes into 2x twice, and 2 goes into 2x x times. Okay, I've rewritten this equation, and what we want to do here is we want to multiply both the left and the right by the least common multiple, which is 2x. So 2x times the left and 2x times the right. So on the left-hand side, if we distribute 2x to our first term, we have 2x times 4, which is 8x. And when we distribute the 2x to the second term, negative 5 over x, we get 2x times a negative 5 over x. And then on the right-hand side, we can see that the 2's cancel out, and we get a 3 times x. And if we look on the left-hand side, we can see that the x's cancel out, and let's cancel that a little better, and we get a 2 times negative 5. So the left-hand side becomes 8x plus 2 times negative 5 is a negative 10, and it's equal to 3x. Let's get that 10 to the right-hand side by adding to the left and to the right the additive inverse of 10, negative 10, which is positive 10. So I'm keeping my equation balanced by adding 10 to both sides, and positive 10 and a negative 10 is 0. So I end up with an 8x on the left, and on the right I have a 3x plus 10. Now I want to get my x terms together combined on the left. So I'm going to add to the right the additive inverse of 3x, which is a negative 3x. And if I add that to the right, I must also add it to the left to keep my equation balanced. Now a positive 3x and a negative 3x is 0. And on the left-hand side, a negative 3x and an 8x gives me a positive 5x on the left, and on the right I have 10. We're almost done. I need to remove this 5 coefficient from my x. And to do that, I must multiply the left-hand side by the reciprocal of 5, which is 1 over 5. But if I multiply the left by 1/5, I must also multiply the right by 1/5. 1/5 times 5 is 1. I get 1x, which is x. X is equal to 10 times 1/5, or 10 over 5, which is 2. And my final answer, or solution to this original equation, is x is equal to 2. Here we have another example of an equation with rational expressions. The first thing we want to do is change the subtraction to add the opposite. Okay, let's move this equation up. And I've rewritten the equation down below here. And what I want to look at is I need to find the least common multiple of the denominators. And when I look at the denominator, I see that I have x plus 3 and I have 5. So I move things over a little bit to fit this in. The least common multiple here is 5 times x plus 3. So what we want to do is multiply the least common multiple times the left-hand side and the right-hand side. So on the left-hand side I multiply 5 times x plus 3. That's on the left. And I can say that's over 1. We can do that so we can see the relationship between the numerator and the denominator. And then 5 times x plus 3 on the right, and I can put that over 1 so we can see our relationship again between the numerator and the denominator. And we can see that x plus 3 on the left in the numerator and denominator cancel out, and 5 on the right between the numerator and the denominator cancel out, and that gives us 5 times x plus a negative 5 on the left, and on the right, x plus 3. So now we want to distribute the 5 to the x, and that gives us a 5x, plus we're going to distribute the 5 to the negative 5, and 5 times negative 5 is a negative 25. And then of course on the right we have x plus 3. Now, our mission here is to get the x's to the left-hand side. So I want to get the x out of the right-hand side, bring it to the left. So what I'm going to do is add to the right-hand side the additive inverse of x, which is a negative x. And if I add it to the right, I must also add a negative x to the left. And a positive x and a negative x is a 0. On the left-hand side, when I add a negative x and a 5x, I get a 4x. And I get 4x plus a negative 25 is equal to 3. Well, now I want to get the 25 over to the right-hand side. So I'm going to add to the left-hand side the additive inverse of 25, a negative 25, which is a positive 25. And if I add positive 25 to the left, I must add positive 25 to the right to keep my equation balanced. Okay, so negative 25 plus a positive 25 is 0 on the left, so the left-hand side becomes 4x. And the right-hand side is 3 plus 25, which is 28. And we are almost done. We need to remove the coefficient of 4, and to do that, we have to multiply the left-hand side by the reciprocal of 4, which is 1 over 4. And if we multiply the left-hand side by 1 over 4, we must also multiply the right-hand side by 1 over 4. So 1/4 times 4 is 1, and we end up with x is equal to 28 divided by 4, which is 7. So the solution to this equation above is x equals 7.